Hi, welcome to another exciting video of physics. And in this video we're going to talk about speed and velocity. And I'm Mr. Tompkins, and this is going to be your lesson. Now, speed and velocity is used interchangeably in our everyday language, but in physics they have two very different meanings, just like distance and displacement did in the last video. Now, speed is the rate that an object changes position. And we usually measure speed as a scalar quantity, and it's found using the object's distance, or the distance the object travels. Velocity, on the other hand, incorporates speed, but it also adds the direction of the position change, which makes this a vector quantity, and it's found using the displacement. Now, one thing that you'll remember from the descent and the displacement videos that we saw before is that distance requires to know the path. You have to know how far the object has moved, whereas displacement only matters for the initial position and the final position, and the path is irrelevant. And so we don't even have to think about it. Now, each of these come with their own set of equations. Speed. In order to figure out speed, it's just the distance divided by time, or d divided by t. Whereas velocity, on the other hand, well, velocity incorporates this vector called displacement and divides it by time. And if we look at this in a working form, we have v equals delta x over t, or velocity equals displacement divided by time, or the final position minus the initial position all over the amount of time it took for the object to change its position. The units for these are interchangeable. Speed is in miles per hour. In physics, we like to look at velocity in forms of meters per second, but we could also do things such as miles per hour or feet per second or kilometers per hour. So let's practice using these equations. Speed practice. We have a car that drives 30 miles east and then 40 miles south in 2 hours. What is the car's speed? Well, let me pull something out here that I can draw on. And so if I look here, the car drives 30 miles east. So that's 30 miles, and then 40 miles south. Okay, good. Now, in order to find speed, we have this equation, speed equals distance divided by time. And so the total distance that I travel here is going to be 30 plus 40, which is 70 miles. Divided by the time, and the time is 2 hours. Okay, so the average speed, or the speed of this object, was 70 miles in 2 hours, which is 35 miles per hour. Okay, good. So that was nice and easy. I don't have to include any kind of directions. Now, if we do another practice using velocity, well, now we have to take into account vectors. And so here I have a car that drives 30 miles east and then 40 miles south again in 2 hours. What is the car's velocity? So let's pull this back out. Let's go ahead and erase what we had. And then we'll start over. Okay, so one thing that we have to know is we have to know that it goes 30 miles east and then 40 miles south. Okay, so now we have to figure out, well, what is the, whenever I add these two, such as 30 miles east plus 40 miles south, then that's going to give me the red vector here, which is going to be, if you can recognize this, it's a 3, 4, 5 triangle, and so this is going to be 50 miles in that direction, whatever direction that is. So now I need to figure out the car's velocity. So in order to do that, I have to do speed. So velocity equals delta x divided by delta t. And this red vector we said was 50 miles. Okay, and so I have 50 miles divided by my time, which is 2 hours. And that gives me 25 miles per hour. That was his velocity. But now we have to come up with a direction. Now this angle right here is going to be gotten, we'll call this angle theta, and I know that tangent theta equals opposite over adjacent, which is 40 over 30. Okay, which is going to end up giving me an angle where theta equals 53 degrees. So my total velocity that this object had was 25 miles per hour at an angle of 53 degrees, and this is going to be south of east. South of east. All right, thank you. I hope this helps in your homework, and then now you have some labs that you need to take care of.